The next thing we need to talk about is measurement precision. If you remember, you have access to these specifications I gave you at the start of this project, so you can see all of the measurements that you were supposed to use in developing your train. So when you model these things, or when you are doing this drawing, you need to pay attention to the number of digits that these measurements are, because that's one of the things we'll be checking. So we're going to go through and do some annotation on this screw so that you can see how to do this. So we will focus on things that are visible in the projected or the orthographic views. Some of the things are not going to be easy to do without breaking rules about how to dimension. So looking at this screw, you can see that everything here looks like it's 2 decimal places or 3 decimal places. So in my example, I'm going to show some that have more than those, and we'll go from there. Okay, so on this, so we're going to go in and do some annotation on this screw. And this is the modified one, so it's a little bit different than what you drew from the spec, but just measure it as it is. So this is not enough decimal places, so you can see how to change that, and I'm just going to randomly set some stuff here. I can see the number it is. It actually has a whole lot of decimal places, and I'm going to go to 4 on this one just because I can, just because I'm just doing an example for you. So when I click on that, now I have that dimension there set very specifically. Again, we would go from here to the bottom of the top part, and let's go to 3 on that one, and then I can go from the bottom edge. Remember, when you're doing these dimensions, go from the one edge to the top edge. So I'm going to go to 3 on this one just to make it make sense, and then I'm going to go all the way to the top. Notice how I'm not choosing the green dots, I'm choosing the lines, and that way my extension lines don't cross over the part. And for that one, we can stick with 1 inch because it's exactly 1 inch. Let's make it smaller. So if I wanted to go to 1.1 then, or 1.0, it would look like that. So now I have some dimensions here. Another thing that we need to dimension is this radius on the outside. It's going to say SR on yours, and that's fine. So I'm going to add this dimension. Notice it goes a long way, so I'm going to make that, for the purposes of this example, let's make it 5 digits. Or 4 digits. So the thing is, you'll want to match the precision that's presented to you. Even if the numbers don't match, you need to match the precision presented to you in that document. Another thing we need to dimension is this. Let's see if this works. How do we do that? So I'm going to pause right now. Another thing to keep in mind is this part is threaded. So I'm going to use the hole and thread tool here to identify this dimension. So I'm just going to click on that outer edge, drag it out, and it tells me that it's a 1/4 inch 20 UNC 1A screw, and that's fine. Another thing we need to use is the chamfer tool, and if I remember right, you click on, let's zoom in, you click on this and then this, and it tells you the chamfer right there. Okay, so again, match the precision of the numbers even if it's not the same as the specification. If you're using the default parts instead of the ones you made, you'll follow that. Another dimension you need to show on this one is going to be the size right here, and I know in the drawing it says so many 30 seconds, and so we're going to change that to, let's go all the way to 5 decimal places on that. Keep in mind when you're doing these, if you're turning in a drawing here, every time you go up, it increases the cost to manufacture that, because the higher the precision, the more expensive it is to machine. Alright, I'm going to pause for a moment and see what else that's strange.